All right, so number 4. So here we have x cubed minus 8, right? So this is a cubic, and it's a binomial. So so I just want to make sure these are both perfect cubes, and that's the case, right? 8 is a perfect cube. And then real quickly, our perfect cubes would be 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and so forth, right? So this list goes on forever, but these are just some of the common ones. All right, and so forth and so on. All right, so for number 4, we see that 8 is a perfect cube, right? And of course, x cubed is a perfect cube. So now we can go into we can use our formulas, right? So I can say, okay, well, I know that if I have a cubed minus b cubed, and let me do the plus or minus. So we'll do a cubed plus b cubed is a plus b, right? And then it's a squared minus ab plus b squared. So that's the format. And so if we change this to a minus, then this changes to a minus and this changes to a plus. Okay. So here I have that format, right? So what I'm going to do is I'm going to change this into a plus b, right? So I'm just going to put a, and it's going to be minus b, I should say. And then here it's going to be a squared plus ab plus b squared equals 0. All right. Now the way you find a and b are the cube roots of these two terms, right? So basically what I'm going to do is I'm going to take the cube root of x cubed, and that gives me x, so I'm going to put x here, right? And then I'm going to take the cube root of 8, which gives me 2, so I'm going to put a 2 here, right? I know it's going to be a minus. So now I'm just going to take a and b and operate with them like this, right? So you can do this mentally, you don't have to write all this down, but just to kind of show you how it works. So now I'm going to do x squared, right? Because a is x. And so x squared is x squared. Put the plus in there. Now I'm going to multiply a times b, right? So I'm going to do x times 2, which is 2x, right? And then here I'm going to do b squared. So b is 2. So I'm going to do 2 squared, which is 4. Okay. And these are the signs, right? So these signs are set, right? Once you know it's a difference, that means it's going to be a negative, or excuse me, it's going to be a negative, positive, positive, right? All right, so that's the factored version of this. Now we have some work to do, right? So I still have a trinomial inside here. This is actually a quadratic, and it's a simple quadratic, but there are no products of 4 that give me a sum of 2, right? My only options are 1 and 4, which could give you a sum of 3 if the signs were different. But here the signs are the same, so that would actually give us a sum of 5. And then the other option we have for two numbers that have a product of 4 are 2 and 2. And 2 plus 2 is not 2, it'd be 4, right? So this is actually a prime polynomial, right? It cannot be factored, so we call it a prime polynomial as one of our vocab words there. So anyway, so from here, the only way to solve this is with the quadratic formula. So that's what we're going to do. So I know one of my answers already is x equals 2, right? But to find our other answer, I'm going to have to plug this into the quadratic formula. So that's what we'll do. So I'll say x equals negative b. So here b is 2 plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is 4, right? All over 2 times a, which is 1. So we'll do all this. We'll do the discriminant first. So so that becomes 4 minus 16. So that'll become negative 12. So we can see we're going to have an imaginary value. I pops out. And then 12 can be broken down to 3 times 4. 4 is 2 times 2. So I have a pair of 2's and a single 3 that's left over, right? So when I rewrite this down here, it's going to be negative 2 plus or minus 2I root 3, right? So the I pops out, the 2 pops out, 3 gets left behind. All over 2 on the bottom. Okay, so now I have a common factor of 2, so I can divide each of these by 2. Right? And all those ones can be invisible except for this one, right? Because there's nothing next to that, so I need that one. So my answer is going to be negative 1 plus or minus I root 3, and then the 1 on the bottom is invisible. So these are my other two answers, right? So I end up with x equals negative 1 plus or minus I root 3. And you can write that as two separate ones if you want, or you can use the plus or minus, and that's fine. Just know that it's two answers, right? All right, so just like we suspected, since we have a cubic, we could get up to 3 solutions, and we ended up with 1 real one and 2 complex ones. All right, number 5, very similar, except for this time it's a sum. So since it's a sum, I'm going to use this format here, but this time it's going to be, give myself a little more space, it'll be a plus b, right? And then it will be a squared minus ab plus b squared. Okay. And so first of all, I want to identify a and b. So I'm going to take the square root, or the cube root of this, excuse me. Cube root of 27 is 3, right? So I'm going to put a 3 here and an x, right? Because the cube root of x cubed is x. And then when I take the cube root of 64, that gives me 4, right? So I'm going to put a 4 here. All right, so remember this is positive, so I'm going to put a plus here because that's positive. And then now I'm just going to do the operation. So a squared, that would be 3x squared. So 3x quantity squared is going to be 9x squared, right? 3 squared is 9, and x squared is x squared. Then here, I'm going to multiply a times b. So it's going to be 3x, which is a, right, multiplied by 4, which is b. So 3x times 4 is 12x. And then don't forget to put that negative in front. Okay, and then the last thing I'm going to do is b squared. So since b is 4, I'm going to do 4 squared, and that equals 16. So it's going to be positive 16 there. All right. So now we are going to solve, right? So for this one, you can go straight to the answer. So we'd have to subtract 4, divide by 3. So it's going to be x equals negative 4 over 3, right? So if you need to, you can set up that equation, right? 3x plus 4 equals 0. Subtract 4, divide by 3. You get the same value. Now this one, now it's a complex quadratic, right? And off the top of my head, I would have to multiply 9 times 16. That would give me 144. Are there numbers I can multiply to get 144 that I can add to get 12? I'm not sure. So I'm just going to do the quadratic formula with this because, yeah, I'm just not sure if it factors. So I don't want to waste time, going through all that when I could just do the quadratic formula. So I'm going to plug all this in. So it'll be, let me bring this up so we have a little more space. X equals negative b, so b is negative 12, plus or minus the square root of b squared, so it'll be negative 12 squared, minus 4 times a, which is 9, times c, which is 16, right? All over 2 times a, which is 9. Okay, so we have a negative negative, which makes it positive. So I have positive 12 plus or minus. And then let's evaluate the discriminant here, everything underneath. So you end up with 144 positive minus 576. And that equals negative 432, right? And so then we take the square root of that. We're going to pop an I out. And 432, let's try to break that down. So 432 is 2 times 216. 216 is actually 6 cubes, so let's just break that down into a bunch of sixes. So 6 times 6 times 6. And then here, since I have a pair already, I can actually just circle that because I don't need to break them down because I'm going to get 2 2s and 2 3s, right? But then I still do want to break down 6 some more. So 6 is 2 times 3. So then I also have a pair of 2s, right? So I have a pair of 2s and a pair of 6s. That means 12 is going to come out. Okay. The I is going to come out. And then all I have left over is this 3 right here. All right. Then on the bottom, 2 times 9 is 18. So now I can reduce. So 6 is a common factor between all these terms, right? So I'm going to divide everything by 6. So this gives me 3 on the bottom, 2 right here, 2 right here. And so we'll end up with 2 plus or minus 2i root 3 all over 3. And so that's our other set of answers here. X equals 2 plus or minus 2i root 3 all over 3. All right. Okay, so that gives you an idea of how to factor sum and difference of cubes, right? It's pretty much the same exact thing, this and this. The only difference is the signs, right? This is plus minus when you have a sum of 2 cubes. When you have a difference of 2 cubes, it's minus plus. Okay, and then that last one is always positive. All right. So then some work from there to do, because then a lot of times we'll have to do the quadratic formula after we factor the difference of 2 cubes or sum of 2 cubes. So yeah, so a little more work to do because of the quadratic formula, but the factoring hopefully is pretty straightforward.